Swayam Prabha. Digital India. Educated India.
Hello student, welcome back to the course on optimization methods for civil engineering. In this particular class, I will solve few problems related to multi-objective optimization problem using MATLAB. Already we have solved multi-objective optimization problem using R software. I hope you could solve some of the problems using R. So today in today's class, I will solve few problems using genetic algorithm, multi-objective genetic algorithm using MATLAB platform. So let us see the function that I will use for solving a multi-objective optimization problem with constraint or without constraint. That function is ZA multi-objective. Okay. So this is the function ZA multi OBJ. So this is the function and these are the arguments. Suppose I have to put function here and number of variables. So these arguments are similar to the ZA arguments or similar to the fmin_con function I have used. So here in this particular function, so I can handle a multi-objective optimization problem with linear constraint, nonlinear constraint, linear equality constraint, linear non-equality constraint and nonlinear equality and nonlinear inequality constraint along with integer variable. So if you have any integer variable, that also you can define in this particular function. So if you have any problem with integer variable, so then also you can use this particular function. So arguments are similar to that you have used in ZA or fmin_con. So in function, so here you have to define the objective function here. Suppose if you have two objective function, then you have to define f1 and f2. If you have 3, then I will define f3. Then I have to define the number of variables. Then if you have inequality linear constraint, then you define A and B, and if you have equality linear constraint, then also you can define. Then you can also define lower bound and upper bound. Already we have discussed that part, so you know how to define lower bound and upper bounds. And if you have non-linear inequality constraint, so this is non-linear inequality constraint, so that also you can define. And if you have option, so you can change the population size, you can change the generation, you can change the crossover probability, mutation probability, and you can also define what type of function you are using for crossover, for mutation, then for selection. So that also you can define here in the option under option. Then if you have any integer then also you can define here. So what I am getting from this particular function, so I will get the optimal value of x, that means the x star I will get. I can also get the function value, then exit flag that I will get the other output, then population scores, so that also I can get from this particular function. Okay, so that as an output I can get when you are using this multi-objective GA function. So I hope this is not difficult, because already you have learned how to solve a multivariable problem or a single variable problem with a single objective function. That means single objective function problem you can solve it. So using ZA function, and the arguments are same. So, the function type is same, only the name of the function is different. So, there I have used GA function, and here it is multi objective GA, or this is basically GA multi objective. Okay, GA multi OBJ, the function name is different. Okay. So, arguments are same. Now, let us see. So, I will solve 3 problems here. So, let us see the first problem. The first problem, we have 3 objective functions. So, we have f1, we have f2, and we have f3, and the functions are minimization type. So, functions are minimization type, and we have 3 objective function. So, how many variables we have? We have 2 variables, that is x and y. Okay. So, f1 is a function of x and y, f2 is also a function of x and y, and f3 also a function of x and y. So, this is the function, and if I solve this particular problem, so I should get this Pareto optimal form. So, I should get this Pareto optimal form, and let us see whether I will get the same Pareto optimal form here. So, I should get the same Pareto optimal form. Now, this is the MATLAB code. So, here what you have to do, you have to write the objective function. So, here we have 3 objective function, that is f1, f2 and f3, and after that, so this is a vector. So, objective is a vector. So, that is with the where we have f1, f2 and f3. So, this we have to return from this particular function. So, these 3 variables are to clear the environment, then you define lower bound and upper bound, and here objective function is your fun. So, this is the name of the function. So, this is the name of the function, and now this is the multi objective GA function. So, GA multi objective, and here I have defined objective in number of variables 2, and then we do not have A, B, A equality, then B equality. So, we do not have. So, I am putting null, null, null. So, empty vector, and then I have defined lower bound and upper bound. So, if you are solving, so you should get the solution of this problem, and then I am plotting this particular objective function, that is, so that is whatever your the solution will be at rest. So, x star will be at basically store at result. So, res here, then f val. So, this is basically will contain the f1, okay, f2 and f3. Okay. So, here so I am plotting that the objective function 1, objective function 2 and objective function 3 as a scatter plot, then I should get this particular plot. So, here I did not define any parameters. So, I have used the default parameters, number of population, default population, I have used all the parameters, I have used default parameters. So, therefore, the population size is less here, and I am getting few points on the Pareto optimal form. Now, if I would like to increase the population size, so what I can do, I can go to option and I can define the population size. Okay. So, here what I can do, I can put this option. So, here I am putting generation 600 and population size 1000. So, I am putting 1000 population size, so that I am getting a continuous Pareto optimal form. Okay. So, I can increase the population size using this option. So, I have increased here up to 1000, and I am using 600 generation, but if you want you can also change that one. So, what changes you have to do on this particular line, that is the multi objective genetic algorithm function. So, I have to put this option here. Okay. So, option, and then these options will be taken. Now, if I execute this particular M file, so I will get the continuous Pareto optimal form. Okay. So, we will see this one. So, when I will use the MATLAB, online MATLAB. So, there actually I will try to run this particular function and to get the Pareto optimal font. So, this is basically, so this you should get, okay. So, if you are executing that particular M file. So, the next problem is a multi-objective optimization problem with constraints. So, we have two constraints here. This is the first constraint and this is the second constraint. Here the objective functions are minimization type. So, this is fine. So, if your problem is a maximization type problem, then you have to convert it to minimization type problem. That means what you have to do, you have to you have to convert it to minimization type problem, which is equal to minus of your fx. Okay. So, suppose I have maximization of fx, so that I can do minimization of minus of fx. Okay. So, I have to do that, but in this case this is a objective functions are minimization type. Now, look at the constraint. So, constraint function should be that g1 should be less than equal to 0 and g2 should be less than equal to 0, but here this is greater than equality type. So, what I will do basically, so I will convert this one, that is g1 x y, okay. So, this is equal to minus y minus 9x, so this is less than equal to minus 6. Similarly, that z2 x y, so what I will do, I will convert, I will multiply it by minus 1, then I will get y minus 9x less than equal to minus 1. So, now this is your less than equality type constraint. So, I can define what is the value of a and what is the value of b. So, in this case a will be this is minus 9 minus 1 and this is minus 9 plus 1 and b will be your minus 6 minus 1. Okay. So, this is your a and b. So, I can put this a and b in the GA multi-objective function, so that I will use. So, this is a problem with constraints. So, we have two constraints and these constraints are linear inequality constraints. Okay. So, linear inequality constraint. So, I have to put what is the value of a and I have to put what is the value of b. So, let us see the M file. Here I am defining what is lower bound and upper bound. So, lower bound is 0.1 and 0, upper bound is 1 and 5, then objective function. So, this is the objective function. So, objective function f1 equal to x1, f2 equal to 1 plus x2 by x1 and we have two objective function. And so, we do not have any nonlinear constraint. So, we have a and b. So, that is equality type linear constraint. So, here this is your a. So, a is minus 9 minus 1 then minus 9 plus 1, okay, and b is minus 6 and basically minus 1. So, this is your b. So, I have defined a and b and then this is the GA multi-objective. So, this is objective function, then number of variables are 2, then I have defined what is a, what is b. A equality, b equality is not there. So, I am putting null and then lower bound upper bound we have defined and we do not have any nonlinear constraint. Okay. So, nonlinear constraint we do not have. So, you can put null here or I can also delete this portion, that is not required, and then I am plotting the objective function 1 and objective function 2. So, I will get the Pareto optimal font. So, this is the code, then you should get this Pareto optimal font. Okay. So, this you should get. So, this is the second problem. The third problem is a multi-objective problem with nonlinear inequality constraints. So, we have two nonlinear inequality constraints. So, what we have to do? We have to write the inequality constraint function also nonlinear inequality constraint function also. So, we have to write a function where we have defined this nonlinear inequality constraint. So, we do not have any equality constraint. So, we will just pass the null vector. So, here we have to define two functions. This is the first function, this is the first function, this is function 1 and this is function 2. Function 1 is the objective function like that. As we have nonlinear inequality constraint, so therefore, I am also defining this is C and C1 and C2. So, we have two constraints C1 and C2 and we do not have any equality type constraint. So, I am just returning an empty vector. And so, this is the function I have defined and this is the objective function I have defined, and then now I am using objective function, then constraint, then we do not have any linear constraint. So, this is we are putting empty and then I am defining this objective function, number of variable is 2, then a, b, a eq, b eq is not there, then lower bound, upper bound I have defined, and then I have also defined nonlinear constraint. Okay. So, we have nonlinear inequality type constraint. Now, if I run this particular function, so I should get this Pareto optimal form. Okay. So, I can increase the population size by using option. So, then I will get a continuous line, or otherwise you will get this particular your Pareto optimal font. Okay, then let us go to MATLAB and just see whether I am getting the similar solution or not. So, let us run this particular M file in MATLAB. Let us solve the first problem. So, this is the M file. So, I will just copy this one and I will go to MATLAB, and here you just see. So, these are just to clean the environment, and then I have defined lower bound, that is -3 and -3, upper bound this is 3 and 3. The objective function is your fun. Okay. So, this is the objective function name. Okay. And then I have used this particular function to solve this problem. So, before that I have to write this objective function. So, here this is the first objective function f1, this is your f2 and this is your f3, and then you have to put in this particular objective function vector. So, here we have f1, f2 and f3. Okay. Now, I have defined this objective function. Now, if I execute this particular file, so I should get the solution of this problem. So, let me run this one. Okay. So, I am getting that one, but what is happening, the population size is less. So, therefore, I am not getting a continuous Pareto optimal form. So, what I can do? I can increase the population size. Okay. So, how I will do that? I will put the option. So, here is the option. So, I can put it. So, this is the option. So, I am defining here the option. So, this is the option, and here I have to define options. Okay. So, now what I am doing here, so I am using maximum generation equal to 600 and population size is 1000. I can also use some different population size. Let me see that one. Then I am using plot function. So, this is GA plot Pareto. So, it will plot the Pareto optimal form in every iteration, and mutation function I have used Gaussian mutation. So, this is your real coded GA, and I have used Gaussian mutation function. So, you can also define what type of crossover function you want to use. So, you can define in this option line. So, you can define, and also you can define the probability of crossover, probability of mutation, then what type of function you would like to use for selection. So, that also you can define. Otherwise, the default function will be used. So, let me execute this particular M file. Now, you just see that I am getting this Pareto optimal form, okay, and this is the final Pareto optimal form. Okay. So, this is similar to what actually I have shown you earlier. So, now our population size is more. So, therefore, you are getting a continuous Pareto optimal, you are getting a continuous Pareto optimal form. So, let me check if I want to suppose the population size 500. So, 500 then what will happen? Yeah. So, I am getting, so now you just see you are getting, but there are some gap, but if you want to increase or if you want to see the continuous line. So, in that case you have to increase the number of population, or suppose I would like to change only the population size and number of iteration, then you can delete this part. So, suppose I do not like to see the plot in every generation. So, what I am doing, I am just defining maximum generation, that is 600, and population size 500. So, let me then this plot will not be shown. So, only you will get the scatter plot at the end. Yeah. So, you are getting this scatter plot. So, it is not showing the plot after every iteration. Okay. So, it is not showing that one. So, you are getting the final Pareto optimal form. So, using option, so I can change the parameters of the genetic algorithm. Now, let me go to the next problem. So, let us see the second problem. So, this is the second problem. So, it has two linear constraints. So, I will show you how you can define this linear constraint. So, here this is the code. Okay. So, this is the code. This is the objective function, this is the objective function, and then I have defined lower bound, I have defined upper bound, and then I do not have any nonlinear constraint. So, I can delete this part. So, this is not required actually. So, as I do not have this one, so I can also remove this part. So, I have two inequality type linear constraints. So, I have defined A. So, A is -9 -1, then -9 +1, and the right hand side B is -6 and 1. A equality, B equality is not there. So, I can also define here. So, I do not have A equality and B equality. So, lower bound, upper bound I have defined, and so I can remove this part in order to reduce the number of lines. So, I have defined what is A and what is B. So, that I have defined, and then objective function is your this one. So, I can also directly define this objective function here. So, I can So, I can define here. So, I have defined the objective function, that is your fun. Okay. Then number of variables is 2, then I have defined A, I have defined B, and after that, so I am plotting the Pareto optimal font using this particular line. And in the objective function, I have only two objective, that f1 equal to x1 and f2 equal to 1 plus x2 by x1, and this is f1 plus f1 and this is f1 and f2. So, this is the objective function. So, let me run this particular file. Yeah. So, you are getting this Pareto optimal form. So, if you increase your population, so you will get a continuous line. I hope this is clear. So, if you have linear constraints, so you can define that A, B, A equality, B equality. So, in this particular problem, we have only two inequality type linear constraints. So, that I have defined what is A, what is B basically. So, and other things are similar to what I have solved earlier. Now, let us go to the next problem. This problem we have, so this problem we have two nonlinear inequality type constraints. So, therefore, I have to write the constraint function. So, let me go to the M code. So, this is the M code. Okay. So, MATLAB code dot M file. So, this is the MATLAB code. So, here first I have to define the objective function. So, objective functions are defined here. So, this is the objective function. So, here this is the f1 equal to x1 and f2 equal to 1 plus x2 into exp. So, minus x1 divided by 1 plus x2, and we have two objectives. So, we are returning this value of f1 and f2, and you also need to define the nonlinear constraint here. So, we do not have any equality type constraint. So, therefore, we are returning an empty vector, and here we are defining f1 and f2, and after that we are defining c1 and c2. So, you please remember that original inequality type constraint was greater than equality type constraint, and but here we have converted that greater than equality type constraint to less than equality type constraint by multiplying minus 1. So, you can see that one. So, this is the minus 1 I have multiplied. Okay. So, now these two constraints are inequality type constraint. So, I have defined. So, now I am returning C and C equality type. So, C equality is null, and then you define lower bound, you define upper bound, then this is the objective function. So, I can directly write the function here. Okay. So, you can directly write the function. I would like to reduce the number of line. Okay. And nonlinear constraint. So, I can also define the nonlinear constraint here. This is the nonlinear constraint. Okay. So, I am defining here. So, I can remove these two lines, and we do not have any linear constraint. So, therefore, I will define it here. So, this is null, this is empty, this is also empty, this is also empty. Okay. So, this is not required. This is the objective function, and number of variable is 2, then this is not there, then lower bound and upper bound I have defined, and then the nonlinear constraint, and after that I am just plotting the Pareto optimal form. So, let me run this particular M file. So, I am getting this Pareto optimal form. So, what also you can do, that this lower bound I can define here also. Okay. So, I can define lower bound, this is 0 and 0, and upper bound also I can define here, this is 1 and 1. Okay. So, I can define here. So, I can remove these 2 lines. You just see this is quite simple. So, here itself you can define everything. Now, let me see, let me execute this particular line. So, yeah, so this is working, you just see. Now, let me use the option. So, what I can do, I have suppose I would like to copy this option, I would like to increase the population size. So, option I will define here and here I will write option, here I will write option. Okay. So, now let me run this one. Yeah. So, I am getting this plot at different generation. Okay. So, you are getting this particular plot. Now, let me see, I will just I would like to increase this one. Okay. So, I am getting this Parrot optimal fawn, and population size I have used 1000, but I can also use suppose what will happen 200 and generation is 600 you keep. So, let me see. Yeah. So, I am getting this. So, I am not getting continuous one. So, but if you are increasing population size, suppose 500 I am using. So, in that case you are getting a continuous line. So, you are getting a continuous line. So, you can sense the population size, you can sense the iteration, and you can also sense the parameters using the option. So, now let me solve another simple problem without this thing. So, I would like to write the code here itself. So, let me open this another M file, but before that the problem here is that. So, I would like to solve a problem. So, this is a minimization type problem and we have two objective function that f1 equal to x square. So, this is f1 equal to x square, f1 equal to x square and f2 equal to x minus 2 whole square. So, this is a very simple problem and the objective function are minimization type. So, minimize f1 which is equal to x square and f2 equal to x minus 2 whole square. So, number of variable here n var is equal to 1 and we do not have any constraint. Okay. So, there is no constraint. So, this is a very simple problem. So, let us solve this particular problem. So, what I will do, I will just copy this one and then I will write. Okay. First what I have to do, I have to define, this is not required. Okay. So, I have to define f1 and f2. So, here I have to define that f1 equal to x basically, okay, and f2 equal to x minus 2 whole square. So, this is very simple. So, we have two objective functions, that is f1 and f2. So, we do not have third one. So, this is my objective function code. So, you can give any name here. So, I am giving the name of this particular function is fun, fun. Okay. So, I have defined what is first objective, I have defined second objective and then I am returning this value f1 and f2. So, here now what I will do, I will use this particular function, that is a multi-objective. So, here the objective function is, this is @fun, okay, and number of variables is 2 and I do not have anything. So, let me delete this part and just see whether I can solve this particular problem. Okay. So, then these are just to clean the environment. Okay. Now, I hope I have defined, and this is I have only objective function and number of variable is 1 here. Okay. And then I am just plotting. So, we have two objective function, that is first one and second one. So, let me delete this one and run this. So, I have to give a name. So, this is problem problem 4. So, here now I have defined the objective function. So, objective function is fine. So, we have only one variable and then a equality a equality b equality is not there, and then I have defined lower bound and upper bound here, and then I am just plotting this one. So, variable 1 I am just plotting, and this is objective function 1 and objective function 2. So, let me execute this particular MATLAB code. So, I should get the Pareto optimal form. So, I am getting the Pareto optimal font here. Okay. So, I am getting the Pareto optimal font. So, this is all about today's class. So, in today's class we have solved few multi-objective optimization problem using MATLAB. So, we have used GA multi-objective function for solving the multi-objective optimization problem without constraint, with linear constraint and with non-linear constraint, both equality type and inequality type. Thank you.